Trigonometry and all our fun radian goodness is what we're going to be covering today. So this is kind of like the second half of pre-calc, what we're talking about today. So a couple reminders. The idea of a radian is that here's our radius, and if you have an angle that's 1 radian, this arc is the same as this piece. Mostly you care about if you're translating back and forth between those two. We use 180 over pi and pi over 180. It's kind of the simplest way that we can talk about it. You could also use 360 degrees and 2 pi or any other combination of radian measure and degree measure, but it's up to you which you want to use. Standard position, we've got our initial side. We're always starting on the positive part of our x-axis, and then we move counterclockwise around our circle for positive angles, and then clockwise for negative angles. So if we have an angle of 5 pi over 8 and a radius of 2 pi, we want to know what that arc length is. It's really easy. It's just this times this. Button, where's the button? This times this equals that. It's really easy in radian mode. In degree mode, there's a whole bunch of other calculations and garbage you have to do, but in radian mode, you just multiply those two together. So you get 10 pi over 8, which you would obviously simplify because we want to give a nice simplified answer, 5 pi over 4. Woot. Sweet. Certain ratios in our triangles that we want to remember is 45, 45, 90 and 30, 60, 90s. The 45, 45, 90 was the easier one because 2 of them matched. And then the other side is square root of 2 over 2. Then for 30, 60, 90, your smallest one is 1. So across from our 30-degree angle, our smallest one is just 1. And our biggest one is our hypotenuse, which turns out to be 2 because of a big proof garbage that we did way back when, but we're not going to worry about it anymore. We've also got square root of 3x. That's kind of our leftover one. I kind of remember that the square root of 3 and the 30 are kind of like right next to each other. So if we wanted to evaluate this thing, so we've got arc sine of 2x, and we want to figure out the sine of x, we're going to sketch this right triangle, and then we're going to try to figure out what all of this stuff turns out to be. So that arc sine. So arc sine was not something that we actually talked about. Well, we talked about it, but we didn't really necessarily write it. Arc sine is actually talking about sine -1. So inverse sine is what we usually called it instead of arc sine, 2x. Inverse sine of 2x, so that's telling us, okay, well, the inverse sine of whatever that is. So that's just going to be some angle. I'm going to pick this one just because I'm drawing the triangle, so I can put it wherever I want. So arc sine of 2x. So this is 2x, because sine is opposite over hypotenuse. And then we're just going to do the sine of that. So really, this inverse sine of 2x, or arc sine of 2x, that is just whatever this angle happens to be. I don't really know what that angle is. Frankly, I don't care. Because then it's just asking me, what's the sine of that angle? Well, I just kind of put it there. Sine is opposite over hypotenuse, so this is just 2x. Other than arc sine, so that is undoing sine, there was also the reciprocal function. So the sine and cosecant were reciprocals of each other. They're upside down versions of each other. Cosine and secant were reciprocals of each other, just flipped upside down. Wait, am I doing this? Yeah, I'm doing this right. What is this? This isn't right. You see how these are both y? They're all YRs. Oh, Honegs. Yuck. So cosine and secant, they're reciprocals of each other. Tangent and cotangent, they're reciprocals of each other. They're upside down versions. There's also this positivity chart. All students take calculus, all senators talk crap, whatever you used. In this quadrant, all 3 of our trig functions are positive. In this quadrant, sine is positive, but tangent and cosine are negative. Here, tangent is positive, but sine and cosine are negative. Here, cosine is the only thing positive. So this is talking about who's positive in what quadrants. There's this thing, the unit circle. I hate this thing. If you really wanted to use it as a reference, you could have it, but this should not live in your brain because it's just, for me, it's too much. What can live in my brain is the golden nugget. And look, I typed this one up so that it looks pretty for you. We've got cosine, we've got sine, we've got tangent. This is how you calculate the other quadrants. Here we've got our positivity chart, important angles, how we created the unit circle, radius of 1, all that good stuff. So make sure that this golden nugget is still living in your brain because it still needs to be in there. We're going to use these a lot and just at random times. You'll never know when it's coming. It's just arcsecant. Once again, that's doing undoing secant. So can I have a pen, please? Thank you. So secant -1 of negative square root of 2 over 2. Square root of 2. I'm getting ahead of myself. Now, one question I probably asked you on the oral exam was, let secant equal negative square root of 2 over 2. Solve for theta between 0 and 2 pi. What angle would have spit out square root of 2 over 2? I keep saying square root of 2 over 2. You can tell where I'm going with this because we didn't do secant. We did cosine. So we need to flip this thing over. So really it's asking about, hey, cosine of theta equals square root of 2 over 2, but negative, right? So I know which angle does that. It's pi over 4. And then there were two quadrants where cosine would spit out pi over 4. It was in the second and the third quadrant. That's where cosine is negative. So it could have been in the second quadrant, it would be 3 pi over 4. And in the fourth quadrant, it would be 5 pi over 4, not 4. 5 pi over 4. Now this one's doing arcsecant, and what that's trying to say is like, hey, we don't want to worry about the additional example. So all we're going to do is we're just going to take the smaller one. So 3 pi over 4 is what we're looking for this one. Here's another one we're going to solve. This one's a little bit closer to what we've done on the oral exam. 2.5, I can make it 5 over 2. So that one's a little bit outside of the range of what I know. I don't know of 5 halves. That doesn't pop up on me. I know square root of 3 over 3, I know 1, and I know square root of 3. But 5 halves, I don't know that one. So I'm just going to use inverse tangent. And I'm going to do this one on my calculator. Let me pause quick while I get that. Double check to make sure that you're on radian mode. So I press my mode button, and I want to make sure I'm on radian for this thing because it's talking about things in terms of radians right there. So inverse tangent is 1.190. But I do care about, for this one, it's giving me that hint of like, hey, I want to be between 0 and 2 pi. So I need the two quadrants where tangent is positive. I know tangent is quadrant in the first positive in the first quadrant, is quadrant in the first positive, and it's going to be positive in the third quadrant. In the first quadrant, we talked about, well, we didn't talk about, but it was on the thing. In the first quadrant, your reference angle, because that's what this thing is. It's my reference angle. It's not my answer. But in the first quadrant, reference angle is my answer. So in this one, it's 1.190. And in this bottom quadrant, we need to do pi plus my reference angle. So let's do that. 4.332.